Hello sir, this is MP Anwar Baba from ECA section. Today my topic is about joint distribution and density functions for random variables. Introduction. Joint distribution refers to the probability distribution that covers two or more random variables simultaneously. It provides insights into the relationship between two random variables involved. Understanding joint distribution is crucial for multivariate analysis and statistics. Random variables overview. A random variable is a numerical outcome of a random phenomenon. Random variables are classified into discrete and continuous types based on the possible values. They serve as a foundation for delivering joint distribution in probability theory. Definition of a joint distribution. Uh, the joint distribution of random variables describes the likelihood of variable outcomes occurring together. For two random variables, it is expressed as p of x is equals to x, y is equals to y for discrete random variables. In continuous cases, it is represented by joint probability density function, joint probability mass function. The joint PMF probability mass function to a discrete random variables, and it gives the probability that each variable takes specific value. It is defined as p of x is equals to x, y is equals to y for discrete random variables x and y. Joint PMF can be represented in a table or a matrix format for a better visualization. Joint probability density function. The joint probability density function is used for continuous random variables and describes the density of probability in a given region. It is denoted as f of x, y as must satisfy the probability that the integral over the entire space equals 1. The joint PDF enables the calculation of the probabilities over specified ranges for the variables. Marginal distributions. Marginal distributions represented the probabilities of a single random variable without regard to the other variables. They are obtained by summing of integrating the joint distribution on the other variables. Understanding marginal distribution helps in analyzing individual random variables in a joint context. Conditional distributions. Conditional distributions describe the probability of random variable given a specific value of another variable. They are calculated using the joint distribution expressed as p of x or y of or f of x or y. Conditional distribution are essential for understanding dependencies between random variables. Independence of random variables. Two random variables are independent if the occurrence of one does not affect the probability of the other. Mathematically, this is represented as p of x or y. P of x, y is equals to p of x. P of y for discrete variables. Examples of joint distributions. An example is the joint distribution outcomes of rolling two dice, which can be represented as joint PMF. In a bivariate normal distribution, the joint PDF probability density function uh, describes the relationship between two normal distributed variables. These examples highlight the diversity of applications of joint distribution in real life scenarios. Applications of joint distribution. Joint distributions are used in statistics, finance, engineering, and various fields. Model relationship between variables. They aid risk assessment, decision making, and predictive modeling by analyzing correct correlations. Understanding joint distribution is crucial for multivariate data analysis, and machine learning algorithms. Visualizing joint distributions. Joint distribution can be visualized using contour plots, 3D surface plots, or heat maps. These visualization helps in identifying patterns, relationships, and dependencies between variables. Effective visualization is key to interpreting complex joint distribution and communicating findings. Key concept to recap. Joint distribution encompass the probabilities of multiple random variables occurring together. Understanding marginal and conditional distribution is fundamental for analyzing joint distribution. Independence simplifies analysis and calculations, making it easier to work with multiple variables. Conclusion. Joint distribution and density functions are vital tools in the probability theory and statistics. They provide profound insights into the relationship between random variables and their behavior. A social grasp of these concepts are essential, uh, essential to effectively analyzing and interpreting multivariate data. These are some references. A.M. Mood, if we grab these are some reference books written by some writers. Thank you.